that day I discussed about these. My screen is visible. Huh. So that day I discussed about these two scientists. Do you know about
No,
them? No? Okay.
I don't know anything about them.
Okay. Just a minute. See, these. Just a minute. Yes. Hello, Razi.
Good evening, ma'am.
Good evening. Razi, I'm discussing about this only, the last class. See, Arham, these two scientists, this scientist is what is happening? Yes. So the name of this scientist is Lavoisier. Okay, and the name of this one is Joseph L. Proust. Okay, Arham.
Okay.
Huh. So these two scientists gave a theory of a chemical combination. They two gave this law. Two important laws of chemical combination. One is law of conservation of mass, and another one is. Arham, my voice is clear now.
Yes, ma'am, it's clear.
And another one is law of constant, or you can say law of definite proportion. So these two laws were given by these two scientists. Okay, one was this Lavoisier one, and the another is Joseph L. Proust. One is law of conservation of mass, and another one is law of constant proportion. So let me quickly discuss about law of conservation of mass. So here, see that they have already discussed. See, what is law of conservation of mass? It states that mass can neither be created nor be destroyed in a chemical reaction. Okay. Here it's saying that your mass can neither be created nor be destroyed in a chemical reaction. Now see, if let's say I'm taking one beaker, okay? And
Okay, so in a chemical reaction, the amount of contents that is produced, that much should be like how much reactants, the mass of the reactant should be equal to the mass of the constant, like, right? So not that like the what like the first, like how it was like before the reaction, the mass should be the same as after
the reaction. Yeah. Yes. So here, let's say this is my beaker, and here is 5 hydrogen and 5 chlorine. Okay. Let's say I'm taking 5 amount of hydrogen and 5 amount of chlorine. And after the reaction, also the amount of hydrogen is same as only this before. Okay. And here also the chlorine is 5, as well as after the reaction it's 5. It's not like your mass is increased 5 to 10, or it's not like your mass is decreased 5 to 0 or 5 to 1, right? So your mass means, let's say if this 5 is my mass, so my mass can neither be created in the sense it's not added up, right? It's not like a 5 to 10 after reaction, and it's not nor be destroyed. Nor be destroyed means like 5 to 1. 5 to 1. It's not decreased also, and even it's not increased also. Okay. Your mass is same in a given chemical reaction, right? Arham, just a minute. Yes, Arham. So, Arham, you understood about this?
Yes,
it's simple only, no? Your mass can neither be created nor be destroyed in a chemical reaction. Let's say this is one more example. Let's say I'm adding two products, okay, A and B, and A is of 1 kg and B is also of 2 kg, let's say. So in the reactant one, let's say I'm getting C plus D, right? So in the reactant one, it will be what? It will be 3 only, because 1 plus 2 is 3. It's not like your mass is increased to 5 while we add 2 plus 1. It's not like it decreased. 2 plus 1 is 1. No, 2 plus 1 is 3 only, right? So your mass is conserved. Your mass can neither be created and nor be destroyed in a chemical reaction. So understood? Okay. And the next one was this one, law of constant or definite proportion. So what is law of constant or definite proportion? See, law of constant proportion. It states that in a chemical substance, the elements are always present in definite proportion by mass. It states that in a chemical substance, the elements are always present in definite proportion by mass. Now, what is the meaning of this statement, Razi? Does it that day we discuss now?
Yes, ma'am, we discussed.
So explain it. Okay, what's the
Ma'am, it means that ma'am, I'm taking the example of water as you took last time.
okay.
Ma'am, in water, ma'am, in any water, like from water, we can take water from ocean, river. We will have a definite proportion for that, like 2 atoms of hydrogen and 1 atoms of oxygen only, and it will make a molecule of water. Like three atoms will join, 2 of hydrogen and 1 of oxygen, to make a molecule of water, H2O.
Yes. So here it states that your chemical substance. Let's say I'm taking water here. Okay, example of water. What is water? Chemical formula of water is H2O. है ना? So here your hydrogen is having two atoms of hydrogen, right? And your oxygen is having one atom of oxygen. And if these two will combine, it will form what? It will form one molecule of water, right? So it's not like we can't write like this, na H3O. No.
No.
And we can't write also like this HO2. No. Only H2 only we will write. Why? Because
There's two atoms of hydrogen and one atom of oxygen.
and this law also states that in a chemical substance, your elements are always present in constant proportion. Okay, it's constant. It's constant. It's not changing. Okay, it's not like H2 will change to H3 or O is having one atom here and O will change to O2. No, H3O2 is not a chemical substance. Your element is constant. Okay. And here, let's say if we will take NaCl, Na is having one atom, Cl, chlorine is also having one atom. It's not like you will write like this Na2Cl or NaCl2. No. है ना? Your elements are always present, constant proportion by mass, or we can say definite proportion by mass. Now let's say if I'm taking example of water only, this is H2O. This is H2O, and here H2O atomic mass unit is how much? Sorry, H atomic mass unit is how much? It's 1. It's there in your periodic table. Okay, let me show you first this periodic table. It will be easy for you. See, let's say this is my periodic table. Okay.
Yes.
So here, see, this is the very best periodic table. Let's say here, this is my boron. Okay, B is what?
Boron.
B is boron. And here, see, above the B, it's atomic number 5 and lower its relative atomic mass. Okay.
Yes, ma'am. I know about the periodic table. I've seen. Yes, ma'am.
Like chlorine atomic mass is 12 and chlorine atomic number is 6. And here it's written state, energy. So, from here, what is the hydrogen? Where is hydrogen? See, hydrogen atomic number is how much?
1.
And atomic mass unit is how much?
Approximately 1.
Yes, approximately. Approx 1. So we will write approx value 1. And here in the oxygen, it's let me check. Oxygen atomic mass.
I think it's like 16.
16. Yes, very good. Oxygen is 6. This one, yeah. Oxygen is 16. So if we will calculate it, hydrogen value is 1. Hydrogen value is 1.
2 to 16, 1 to 8.
Adam?
2 to 16 or 1 to 8.
Yeah, 2 into 2 plus 16. So it will be 2. And if we will find the ratio, it will be 2 is to 16, right? So it will be 1 is to 8. And let's say if I'm taking water from anywhere in this whole world, let's say I'm taking ice water, let's say I'm taking river water or sea water. So the ratio of water will be same only if you will take water from anywhere in this world, right? The water ratio will be same. It will not change. That's why the statement states that your elements are always constant. It's not changing. It will never change. Okay. So these two laws was given by these two scientists, Lavoisier and Joseph. One was law of conservation of mass. It means your mass can neither be created nor be destroyed in a chemical reaction. And the second one was a law of constant or definite proportion. It means your mass is always what? It will not change. It will be constant, right?
Yes, ma'am.
So understood? Any doubt at him in these two laws?
No, ma'am.
Okay. So the next scientist was this one, Dalton.
Oh, Dalton, I know. He thought that like he discovered like about atoms, and he thought it was indestructible.
What did he?
Dalton thought like he thought the idea called atom, like, and then and he thought it was like indestructible.
Yes. So Dalton gave. See, first point is all matter is made up of very tiny particles. That is matter. That is atom. है ना? So
Yes.
this law was given by this Dalton. Okay.
Dalton, yes.
And the second point is atoms are indivisible particles which cannot be created or destroyed in a chemical
Destroyed
reaction.
in a
We have
chemical.
already discussed this point that if you will do some chemical reaction with any of the chemical substance, your atom will not create also, it will not increase also, as well as it will not decrease also.
Yes,
So the third point which was given by this Dalton is atoms of a given element are identical in mass and chemical properties. Now what is the meaning of this point, Adham? The atoms of a given element are identical in mass and
Yes,
chemical
like so,
huh.
like if an atom, if there's like an if there's an atom of like wait, let me think of if there's an atom of argon that can exist. If there's an atom of argon, then it will. If there's another atom of argon, it means that it will have this identical mass and chemical properties.
Okay. Now, what? Huh. So, Razi, are you saying something?
I wanted.
No, ma'am, I was just answering your question.
Oh,
Ma'am, but
okay.
Arham told right.
Oh, okay, good.
Like was like Dalton wasn't fully right, ma'am?
Why?
Because he thought like the atoms were not made up of smaller pieces, but they are like that.
Yes, ma'am. Ma'am, I was also surfing on internet. Then I found an article that limitations of Dalton's theory. And when I discovered it, it was saying that, ma'am, can you explain it more deeply? I was not able to understand.
Like
Which topic?
Ma'am, limitations of Dalton's theory.
Okay, it should.
Theories.
Yes. No, the next topic is atoms. Okay, I will explain. First, let me cover this topic. After that, I will explain. Okay.
Okay, ma'am.
But surely, I'll. Okay. So this after this, should I start atoms and atom?
ma'am, actually, I have like known about this like Dalton history for a long time. Like first Dalton thought it was an instructor, and like few other people came. I know like who they are and what they discovered.
Okay. Okay. Good. So the next point. The next. Where is Shazan? Why Shazan is not here? Advika also.
I don't know.
You don't know him? Okay. So this point, atoms of a given element are identical in one. Let's say if I'm taking this example, helium, in this box, lots of helium is there. Okay. So let's say if I'm taking this helium, okay. So the mass of this helium is same, and also the property of this helium is same as of this helium. है ना? If let's say in box, if there are two arhams, so the one arham here and everything will be same as the another one. Okay, just for example, no, this is not the right example. Here, let's say this is helium. So the mass of one helium is same as that of the another helium, right? And the property is also same, है ना? And if let's say I'm comparing helium with hydrogen, then what will happen, Arham? The mass of these two will same or different? The mass of helium and hydrogen
Same.
is
Sorry, different. Helium and hydrogen is different.
and property is also different, right?
Yes, sir.
So that's why this statement is saying the atoms of a given element are identical in mass and chemical properties. Means the same elements will have the same mass and they will have the same chemical properties. Here, let's say in hydrogen, these two hydrogen will have the same mass and same chemical property. And if let's say I'm taking any of the two atoms, let's say helium, sodium, anything, then they both will have the different mass and different chemical properties. Okay?
Yes, ma'am.
But the same one will have same mass and same chemical property only. Okay, so the next point is, these 3 points are clear. One is atom is made up of very tiny particles. Second is neither be created nor be destroyed. And the third one is the atoms are identical in mass and chemical property. Okay?
Yes, ma'am.
Now, the next point is atoms. Yeah, this is also the same point. Atoms of different elements will have different masses and different chemical property. The example is this only, helium and hydrogen. These two are different elements. So the atoms of these two will have what? Different masses and different chemical property. So this statement is also correct. Now, the next one is atoms combine in the ratio of small whole number to form compound. Now, what is whole number, Adham?
Whole number is like non-fractional value.
Non-fractional. Zero is a whole number? No? Zero.
Zero. Yeah.
Zero is a whole number, right?
Yes.
Zero and all the natural numbers are whole number. So here it's saying
So zero is not a natural number.
Natural number is like 1, 2, 3, 4, 5, 6,
It's not including zero.
and zero included and natural number included is together a whole number. Now it's saying atoms combine in the ratio of small whole number. It means it's not like we can't write like this 2 by 3. Oh no, right?
No.
No, we will not write like this. We will write like this only, H2O, because 2 is a whole number. and 2 by 3 is a fractional number.
Oh, that's why in like balancing chemical equations, we have to multiply everything
Yes, we have to divide everything by denominator, है ना?
or multiply. Yeah.
Or multiply, yes. Because we want that particular thing to be in a whole number, right?
This one.
Okay. So next one. Next theory is the relative number, the relative number of kinds of atom are constant in a given compound. Constant in the sense, if I'm taking example of NaCl, or if I'm taking example of H2O or anything like Na2SO4 or anything, it's constant. It will not change. The same as before, like Na is having one atom, fluorine is having one, H is having two, oxygen is having one. So here is what atoms are constant in a given compound. Your H2 is a compound, hai na? So your atoms are constant. It's not changing. We can't write H3, we can't write HO2. Your atoms are constant from starting. H2O, it means H2O only. It's not H3O. Okay, got it. So these 6 theories was given by this one. Okay, one was atom, second was created, destroyed, third was identical, fourth was different, and the fifth was whole number. The sixth one was very easiest one. The it's saying atoms are constant. It will not change. Okay.
Okay.
So let's talk about atoms. What is atom? Huh?
An atom is like there are 118 of them. As like this is the smallest particles, which like they're the smallest particles of an element. I have no idea.
Okay. So let me atoms. Atoms. It is the smallest unit of matter. This we all know, right? It is the smallest unit of matter. Which may or may not have an independent existence.
Oh! I got it. Like only the noble gases can have independent, existence.
May or may not have an independent existence, but always takes part in a chemical reaction. But always takes part in a CR I'm writing, okay? Chemical reaction. Okay, let me write some CH. Chemical and then RE. Yes, chemical reaction. So what it says it's the smallest unit of matter. Obviously, atom is the smallest unit of matter, which may or may not have an independent existence. Atom may or may not have its own independent existence.
Man, there's only 6. There's only 6 like elements that can have independent existence.
What are that?
There are only 6 elements that can have independent existence.
What, 6?
There's only 6. I'm saying there's only 6 elements that have independent existence.
Really?
Yes, they're only the noble gases. Other
Yes,
ones
helium, neon, krypton, argon, right?
Yes, ma'am.
So here, but always takes part in a chemical reaction. This is also correct. If I'm writing H2O here, this is all. This is what? H is having 2 atoms.
Yes.
Oxygen is having 1 atom. So it may or may not have its own independent existence, but it will always take part in a chemical reaction. If I'm writing any compound, let's say NaCl or anything, Na2SO4, CaCl2, everywhere you see that your atom is included. Sodium is having 2, SO4 is having, SO is having 4, calcium, chlorine is having 2. So atom always takes part in what? In chemical reaction. Helium is that noble gas. Helium is also a noble gas.
Helium can just be like on its own.
Helium is less reactive. It freely exists. Helium is what? All the noble gas are what?
It can freely exist.
Less reactive.
Because all the electrons are there in all the electrons are fulfilling every spot.
Yes. And your helium is less reactive, but what about your hydrogen?
Hydrogen is more. It can't be on its own.
Hydrogen is more reactive, yes. Because the chemical formula of hydrogen is H2. So here is what? Here 2 is there, means atom is included. So this is what? This is more reactive. And all the noble gas, helium, argon, krypton, they are what? Less reactive.
Less reactive.
Okay. So now, what is how we will measure atomic radius?
Atomic radius, I don't know.
Okay, Razi, what about you? Atomic
What's
radius
the atomic radius?
is measured in what? Come on, tell me. Think. Arham. Don't Google it. Arham. Razi, do you know what is how we will measure
No,
this? Okay,
no,
so,
I also don't know.
what is this? NM.
Nanometer.
Yes,
Yeah.
ma'am, nanometer.
I thought it was micrometer.
Micrometer. Okay, no. This is nanometer. So atomic radius is measured in this only, and nanometer. So, and what is 1 nanometer?
Like, very small.
Very small. How much?
Ma'am, ma'am, I think 1 to the power -7 meter.
Oh,
Think
my,
like
no.
like some more.
More.
Like
Think.
like 1 power minus like
No, it's 10 to the power -9 meter.
10 to the power 9.
Yes, 10 to the power -9.
1 power 10. Oh yeah, this plus.
Okay.
Yeah.
Atomic radius is measured in this nanometer, and 1 nanometer is this 10 to the power -9 meter.
Yes, that's
Now let's
very small.
here also it's written. Atoms are the smallest particle of element. Okay, same definition, which may or may not have its own independent existence, but it will always take part in what? Chemical reaction.
Chemical reactions.
है ना?
I've
Like,
seen these symbols. More, it says like modern day symbols of different elements. I've
what,
seen
you know? See
I've
here.
symbols.
Here. See, these all are symbols.
No,
Name of
ma'am,
it.
I'm saying like modern day symbols. It was showing.
Oh, this one?
Yeah, I've seen these.
Okay, modern day symbols.
But I just can't. I can't distinguish carbon and oxygen.
है ना?
Yeah.
Yeah, we can't, but it's like only the C and it's carbon oxygen. But this diagram we can't. Okay. So here, atoms of hydrogen, oxygen, nitrogen, etc. are not capable of independent existence, whereas atoms of these two are capable, right? All
Yes.
the noble gas are capable.
Yes.
Okay. What is the size of atom? It is measured in nanometer. It means 1 nanometer is equal to 10 to the power -9 meter. And hydrogen atom is the smallest atom. Its radius is 0.1 nanometer.
Yeah, so I guess the width will be like -10 to the power of like 10 to the power -10.
What?
Something. I think it's width. Yeah, it will be like something like that. Yeah, its width is very small.
It's very small.
Yes, it's very small.
Yes, it's very, very small. Okay, no, Aram,
How did they
this
measure
is
it?
wrong. Aram, this is wrong. Here the carbon, the symbol of carbon is this, like this. It's colored.
Oh, that's
Black in color. It's,
Oh, I was actually looking for that. I've seen like black in color.
it's what?
I've seen like that type of carbon like filled with black color. I was looking for like what is it?
Yes, it's black in color. This is wrong. Okay, so here these are the modern day symbols. Why modern day symbols?
Because it was not there like in a lot of.
In chemistry, symbols are representation of an element. It is simple to use the symbol of element. Obviously, if I have to write sodium, then SODIUM. Instead of this whole thing, I'll write only this Na. है ना?
Yes.
Hydrogen only H, chlorine only Cl, boron only B, nitrogen only N, carbon only C. And what about gold?
What?
Gold.
Ma'am, AU. Ma'am, AU.
Gold is AU.
And what is AG?
AG. I've no.
AG. Yeah.
I have no idea.
AG is the symbol of silver.
Okay, I keep on forgetting that.
And what about HG?
Hydrogen.
No.
Helium.
No, helium is
Keep on
HE.
forgetting. Yeah, that's HE. HG was.
Razi, what about HG? That
Helium? I don't remember.
helium is HE, no? HE is
What?
helium. HE is helium.
Yeah.
H is hydrogen. What about HG?
I think it was like something like germane. No, it can't be that one.
Okay, let me give you a hint. It starts with the letter M.
Magnesium.
No, magnesium is Mg. Razi, tell me.
Ma'am, is it mercury?
Yes, it's mercury. Good. Aram, it's mercury. Okay. So, okay. So these are what? These are the modern day symbols. Hydrogen is represented with only
Just
one dot.
one dot.
Carbon fully covered. Oxygen
Oxygen
only
just
O.
a ring.
Phosphorus. It's a symbol of kind of BMW.
Kind of piece.
Okay, yeah, kind of.
Yeah.
Silver is Christian type. Iron is only I. Copper, Cu, L, lead, S, silver. Gold is something. Okay,
Like
very
a
sunny.
gold, like a cog something.
Platinum, P, Mercury is
Mercury
like
is like the sun or something.
sun. Yes. So these are what? These are the modern day symbols. Now, what is this? As Dalton symbol for elements were different to draw and inconvenient to use. Modern symbols for the elements were introduced by JJ, and these are defined as a shorthand representation. Okay, these are what? These are the shorthand representation. But we only write H, we only write C. We never write like this, na?
Yeah.
We never write like.
I've seen it somewhere.
Huh?
I have seen these somewhere.
Okay, these symbols.
Yeah, I have seen this.
But we never write like this. If let's say for Mercury, we'll write Hg. We will not write like, okay, like this. Let's
I've
draw.
never seen that symbol.
No, yes. Okay, so next one. In the beginning, the name of elements were derived from the name of the place where they were found for the first time. Okay, like nowadays, it is the IUPAC. What is IUPAC? International Unit of Pure and Applied Chemistry, who proves the name and symbols of the element. Many of the symbols are the first one or two letters of the element's name in English. Let's say what?
Like,
It's a hydrogen.
yeah.
Hydrogen first symbol is what? H. So the hydrogen symbol is H. है ना? What about aluminium? It's saying we will take this first letter, or we can also take first and second letter.
Oxygen, nitrogen.
So here, see, it's saying we can take first letter, or we can
Or
say
both the letters, first and
second letter. Yeah, both the letters. So the aluminium is Al. है ना?
second.
Right? So here we are taking this both letters. And what about, and here one more theory should be there, key symbols of some elements are formed from the first letter of the name, just like this hydrogen and a letter appearing later in the name. Okay, now see, it says, here I will write, it says that symbols, now you guys will give me the example, okay? I'm only writing the definition. Symbols of,
My battery is low. I'll just get my charger.
okay, are formed from the first letter. Yes.
Ouch.
Done? Arham?
The first letter appearing in the what name?
Okay, let me read. Symbols of some elements are formed from the first letter. Okay, let's hydrogen, aluminium. Okay, of the name, and a letter appearing later in the name. So give me the example. Come on, fast.
Magnesium.
Magnesium. Magnesium also, it's Mg. More.
Second.
Arham, where are you going? My voice is audible? Razi, my
Yes,
voice.
ma'am.
Okay, what about Arham? Where are you? Maybe your network issue, Arham. Okay, let's wait for her. Hello, Arham.
Ma'am,
What happened?
Discharge. Ma'am, I think chromium. Something.
Huh?
Chromium.
Chromium.
Yes. Number 24. It's CR.
Yes, it's Cr. Zinc is also there.
Yes.
Zn. Chlorine is also there. It's Cl. Yeah? So one first letter, and after the letter appearing later, it means
Manganese.
manganese. Man. It's Mn?
Yes, it's Mn.
Okay, then it's manganese also. Now, the next one. This is the
Also like techinum something, like it's a radioactive number atomic. It's 43.
periodic table. Okay, good. Okay. So, next one. Other symbols have been.
Nibirium, something like that. Number 41.
What? Liberia?
Yeah, number 41 and also number 40.
Okay, let me check. Where is it? Number 40. Here.
Yes, number 40.
Number
No,
40.
no, 40, 41. 41.
41 is Nibonium. No, but here it's NB, it's not NO.
Oh, yeah. But it's appearing later in the name. NIOB.
Oh, yes, it's NIOB. And
also 43.
yes. TC, yes.
Yeah,
Many are there, na?
Yes.
Now, Next one. Next one is other symbols.
Oh, also like hafnium.
What?
Hafnium.
Hafnium?
Yeah, HF 72.
See, other symbols have been taken from the
Place where they were found.
name of elements in Latin, from the names of elements in Latin or German or Greek. Any
Where
example?
they were found, right?
Huh?
Where they were found.
Any example here?
Iron,
Yes. More?
copper, I think.
Ma'am, sodium.
Yes, sodium.
Sodium and potassium K.
Yes, yes. Potassium also. Okay. So these are what? These are of three types, है ना? Symbols of elements are of three types. First was what? First was the first letter,
First letter.
or the second one. The both.
The second
Like
type was like
hydrogen.
it's appearing later in the name.
The second example is this, later in the name. And the third one is
Third one is like it's not even appearing in the name. It was
And
derived from the place it was found.
yes. And what is the atomic radius is measured in what?
Nanometers.
And 1 nanometer is?
10 to the power of minus 9 meters.
No, it's 10 to the minus 5.
You wrote 9, right?
No, I wrote 5.
Yes, ma'am.
It's
Ma'am, you wrote
9.
9.
Yeah, it's 9 only. It's 9. I'm just confused. It's 9. Yes. Good. Now, so this, what is this? Iron, Fe from ferrum, Au is aurum, K from calcium, C is chlorus. This is Greek. This is Greek name. These three are Latin. This is German, cobalt, and the Latin is last one is for sodium is natrium. Okay.
Okay.
Now, this, what is atomic mass? Atomic mass is AMU, atomic mass unit. Or we can say what? AMU full form is atomic mass unit only, no?
Oh, what is Mom, what did you write? AMU?
No, it's AMU,
Okay.
atomic mass unit. Or we can write U only. U is what? Unified mass. Okay? U is only unified mass. These two is the standard unit for measurement of atomic mass. We can write AMU or we can write U. Now, what is 1 AMU?
Mom, how do we even measure it?
That's what. What is 1 AMU? No? Any idea?
0, like very small.
In kg. 1.67 into 10 to the power minus 27 kg. This is
embarrassingly small.
what?
That's embarrassingly small.
It's very small. Yes, it's very small. So 1.67 into 10 to the power minus 27. Now, carbon 12 isotope was chosen as the standard reference for measuring atomic mass.
Also, carbon 12 as
Now,
the
what is
mass
isotope
one.
and what is isobar?
What's an isobar? I have no idea.
What is isotope? Come on, tell me, what is isotopes?
I don't know.
Rizzy?
Ma'am, I also have no idea.
Okay. So isotope is it's having same number of proton, but different number of neutron. And what about isobar?
I don't know.
What?
I don't know.
You don't know?
Yes.
Okay, so isobar is like nuclear species, all of which have the same mass number.
Ow.
It's having same mass number. So isotope is same number of proton, but different number of neutron. And what is isobar? Isobar is same mass. Now here, carbon 12. Carbon 12 isotope, it means your carbon is having same number of proton, but different number of neutrons. So this carbon 12 isotope was chosen for what? Was chosen as the standard measure for referring this.
So, carbon 12 is 1 AMU.
Yes.
Oh.
Yes, Arhan, yes. 1 AMU is a mass unit equal to exactly 1/12 of the mass of one carbon atom.
Okay, got it.
It's 1/12 of what? Of a carbon atom. Is what? It's 1 AMU. 1 AMU is what? Is exactly equal to this 1/12 mass of one carbon atom, C12.
Got
Okay?
it.
So it's already 6:50.
Yes.
So we will continue in the next class about atoms molecule, but first of all I will tell you about that, the limitations, limitations of Dalton's atomic theory.
Yes.
So okay, now it's your assignment time.
No. We don't have a sun time also.
So it's over.
Yes.